Today we're talking about experimental design. So in this unit, we're going to differentiate between experimental and non-experimental design. You've probably spent a good bit of your career in science classes learning about the scientific method. Okay, so at this point, you should probably understand the steps in the scientific method. This unit, we're going to talk about descriptive research. If I'm curious about something, I might first go out and just try to get some background information. I might conduct what's called a naturalistic observation, where I'm observing people, but they don't know that I'm observing them, and I'm collecting data. I might send out a survey. I might conduct a case study, which is a study of one person in particular who might have some kind of unique characteristic. We're going to learn about a woman whose amygdala, which is the part of your brain responsible for your fear response, was actually so calcified that she's unable to feel any kind of fear. That's a case study. This is going to give us some descriptive information that we could use to form a hypothesis. But this type of research is not going to lead us to any kind of broad, generalizable conclusions. So where we're trying to get is to figure out, well, how can we perform an experiment so that we can reach conclusions that we can generalize to a population that is larger than just the one that we've studied. We are going to talk about correlational research as well. We're going to talk a lot about why correlation and causation cannot be confused. Just because two variables are related to one another, like for example, the amount of sleep a student gets and their grades, that doesn't necessarily mean that the amount of sleep a student gets actually impacts a student's grades. To determine any kind of cause and effect relationship, we need to perform an experiment. And that's what we're going to start talking about today by discussing experimental variables. So let's say I want to find out if the amount of time that a student sleeps the night before a test has a positive or negative impact on their test scores. The word impact is really important because the word impact suggests a causal relationship. I can't do correlational research. I can't just do a survey if my ultimate goal is to show that the amount of sleep actually influences grades. So when we're designing our experiment, we need to decide what our independent variable is going to be. In other words, what variable we are going to manipulate in the course of the experiment. I'm going to likely have, we need to have two groups. I'm going to have a control group and an experimental group. My control group, we might not change their sleep habits at all. We just might say to them, hey, sleep. Whereas I might have even two experimental groups. Maybe I have a group where I say, you're going to sleep 5 hours a night. And I have another group, another experimental group where I say, you're going to get 8 hours of sleep a night. Okay? So the variable that I'm manipulating here is the variable that I want to test the effect of. And in this case, it's the amount of sleep that a student gets. Dependent variable is how we measure our outcome. We say it's dependent because it's dependent upon the manipulation of the independent variable. This is our effect. So in this case, our dependent variable is going to be the student's test scores. We're testing the effect of sleep on students' test scores. Probably the best mnemonic device I've ever seen for remembering independent, dependent variables, and also how they are plotted on a bar graph, which we're going to do later in the unit, is dry mix. The dependent variable is the variable responding to the change in the independent variable, and it's always plotted on our y-axis. Y-axis. Our independent variable is our manipulated variable. It's the variable, in this case, the amount of sleep that a student gets that we manipulate in order to bring about some kind of a change. In this case, their performance on a test. Our independent variable is always plotted on the x-axis. Okay? To go back to this graphic that I showed you a few minutes ago, let's say we want an experiment. We're going to run an experiment that will test, that will see the impact that distracting sounds have in the testing environment. Step back for a second, look at this. What is the causal language in this statement? Affected by is the correct answer. This is by saying that distracting sounds will affect test scores. You're suggesting that we are trying to suggest rather that the amount of sound that a student is exposed to, or the amount of the level of distraction that they're exposed to, is going to impact or affect their test scores. So again, we are going to have an experimental group that's exposed to distracting noise, and we're going to have a control group that's not exposed to distracting noise. So think for a second, pause the video. What is the independent and the dependent variable in this scenario? Our independent variable is the distracting sounds. If we're talking about levels of the independent variable, we're going to define our independent variable as either being exposed to distracting sounds or taking the test in a quiet room. Our dependent variable is going to be students' test scores. The one thing I want you to be really, really careful of is if you are asked for an independent and dependent variable, you do not want to give me the group. You don't want to say the independent variable is the group that is exposed to distracting sounds. No. If I asked you for the experimental group, sure, tell me the group that's exposed to distracting sounds. But if I'm asking you for the independent variable, I want to know it's whether or not students are exposed to distracting sounds. The dependent variable, how we are measuring the outcome or the effect of those distracting sounds, are students' test scores. So let's do an example from the irrational game, because you're going to do some practice that's actually pulling apart the research from the irrational game to identify independent and dependent variables. Researchers wanted to see whether representation of an item had an impact on the participants' willingness to pay. They asked participants to view a series of food items and indicate how much they would be willing to pay for each item. Participants were randomly assigned to see either a text descriptor with the food's name, a high-resolution picture of the food, or the food itself displayed on the tray. So before we get to our prediction of how we think this turned out, because you actually might remember from when we did this in class, I'm just focusing on the scenario. Pause the video. Identify the independent and the dependent variable. Now that you've had time to do that, let's go back. Researchers wanted to see whether the representation of an item had an impact on. Here's our causal language, so we know we're doing an experiment, right? Participants' willingness to pay. We can actually see in the first sentence what the independent dependent variable is. Here's our independent variable right here. How the food item is represented. And here's our dependent variable. Participants' willingness to pay. Now, you can't stop there because we're going to learn about something called an operational definition. When we are defining variables, we have to define them in such a way where replication can be done. So what that means is we want another group of researchers to be able to look at our research and replicate it. Do it again. And that means that we have to be really specific in the way that we define our variables. So what I would actually be looking for here as the definition of the independent variable is everything you see right here. Participants were randomly assigned to see either text descriptor of the food's name, high-resolution picture, or the food itself displayed on a tray. That's your independent variable. Okay? Just want to make sure that you're always giving an operational definition and being as specific as possible. And if you remember back to the irrational game, this was the outcome. I won't go over it again because we've already talked about it. Love this. Hopefully you get it. Who was the genius who decided to call manipulated variable independent? Get it? Ha. Someone who can be manipulated as an independent. Anyway. All right. So just to wrap up, to again stress the importance of an operational definition. We must always define our experimental variables, our independent and dependent variable, in such specific ways that the experiment can be replicated. Because the operational definition tells the researcher exactly what they should do and what they should observe. It defines the operation, hence operational definition. It defines the operation or the procedure for the experiment, and it is critical for replication.